All right, so we're going to be continuing 4.1 trig identities. We're going to be trying to establish some trig identities. Here's a quick one that you can try on your own as a warm-up. Feel free to pause the video and give it a shot on your own. I'm going to be going ahead and going through it. So based on what we've done so far, I think the best method for us would be to rewrite everything that's not in terms of sine and cosine on the left side of this equation to write it all in terms of sine and cosine. So we have these two right here, tangent and cotangent, which can be written in terms of sine and cosine. So tangent is equal to sine over cosine. That's one of our quotient identities. And this is getting multiplied times cosine, which can also be written in terms of sine and cosine using more quotient identity. So cosine over sine. And once you write it out like this, it seems pretty obvious that some of these things are actually going to simplify out quite nicely. You can see when we're multiplying these are simply reciprocals of each other. These cosines will cancel, these sines will cancel, and we'll end up with just 1. 1 minus cosine squared. That cancels out nicely, but we're not quite there yet, right? We still want to demonstrate that left side is equivalent to sine squared. So what can we do here? What's a relationship between cosine squared and sine squared? Well, the thing that jumps into my mind is our Pythagorean identity. So this is our first Pythagorean identity, sine squared plus cosine squared equals 1. So this is our first Pythagorean identity. And there's actually a version of this solved for sine squared that says sine squared theta equals 1 minus cosine squared. So at this stage, we sort of notice this nice relationship in our Pythagorean identities. We can see, all right, 1 minus cosine squared, that's just equal to sine squared. And we're done. That's what we were demonstrating. We wanted to show that left side was equal to sine squared, and we were done by making use of this Pythagorean identity. You know, there are a couple other ways to go about it, but they all involve making use of this Pythagorean identity in some way. All right, let's go ahead and clear this and move forward to some of the things we're going to talk about today. So we have kind of technique 0, which is sine and cosine. Put everything in terms of sine and cosine and try to make it work that way. That's a fine method. We're going to keep using that. It's just maybe there are faster ways or other ways that other things that need to happen beyond this, that this won't be the only thing that you'll be able to do. Now, it's very powerful. This technique is very powerful, writing things in terms of sine and cosine, and you'll be able to solve many of these identity problems doing this. But there are some other things in here that we need to keep in mind. So we're going to try to go through some examples of each of these. So finding just the right Pythagorean identity can be awesome. So like on that last warm-up problem, we found a nice Pythagorean identity that was necessary for finishing that out. Fractions. Sometimes we're going to have fractions. We're going to have to get a common denominator to put everything together. Doesn't matter if it's sine and cosine already. We're still going to have to be able to put those together. It's going to be an important skill in there. Factoring, sometimes factoring can really unlock a problem. So either factoring by GCF or difference of squares, we'll kind of look at both of those options. And conjugates. Conjugates is kind of difference of squares, but we kind of want to focus on times where we might have something like 1 minus cosine and say this is in a fraction or something, I don't know, like over tangent. We could do something where we work with conjugates, where we end up multiplying this by 1 plus cosine, multiplying these conjugates together to get something to work out for us nicely. And we'd obviously have to do the same thing on the bottom here in this case too. But when you do this, you might unlock a problem. So making use of those conjugates. We'll kind of go through each of these things. We'll probably only go through a couple of these in this part 2 video, and we'll do a little bit more in the next part. All right, so it's really important to keep this in mind. These can be super frustrating. You can do a bunch of work and it just doesn't work out for you. Maybe you miss something along the way, you make a small mistake, you just can't quite see how you get it there. It's okay. Just start over. Erase stuff, start over. Try something else. If one Pythagorean identity didn't really help you, didn't really get you anywhere, try a different one. If you were trying to do something like that and you haven't tried writing it in terms of sine and cosine yet, try writing it in terms of sine and cosine. Try other techniques. There are often multiple ways to get to it, and some of them are hard, some of them are easier, and you just gotta try. They can be dastardly. All right. So here's one involving some Pythagorean identities. All right, so we're looking at this. We got sine squared, 1 plus cotangent. Just straight off the bat, we could do this. We could do this without the Pythagorean identities. Well, at least without any sort of fancy Pythagorean identity at the beginning. We could distribute this in. We could write everything in terms of sine and cosine, and we could work this out, and it's probably going to work out. Let's just show that. Let's first write this in terms of sine and cosine. Doesn't really matter when I do it. I'm going to go ahead and distribute first. So it ends up being sine squared plus sine squared times cotangent squared equals 1. Let's go ahead and rewrite cotangent. So cotangent is cosine over sine. So I end up with sine squared plus sine squared times cosine squared over sine squared. Here we go. Here we can kind of see some things simplifying out. This sine squared and this sine squared cancel. Leaves us with cosine, oops. Let's erase that. Sine squared first plus cosine squared. And yeah, this equals 1, right? This is just our most basic Pythagorean identity. This equals 1. We've verified it. So we had to use a Pythagorean identity, but it wasn't maybe the one that I was thinking of right away. But we turned everything in terms of sine and cosine. We found that right Pythagorean identity to make things work out for us. It was not too bad. Let's look at this in a different way. Let's actually back up. Let's look at something we can do, something that we might be able to replace cotangent or even cotangent plus 1. Let's just kind of see what I can do with this. So see what we can do with cotangent or cotangent plus 1. So I'm gonna back out of the slides here, and I'm gonna go to some formulas. All right, so I'm looking for something for cotangents. So I'm gonna be looking at these here, or this right here. So these are my 3 that have cotangent in them. And I'm looking right here. This one looks great. 1 plus cotangent squared. We have that exact same thing in our problem. And that just equals cosecant squared. I can make a nice substitution right there. Let's do it. Right? Let's clear this stuff up, go back. And so the identity we were looking at was that 1 plus cotangent squared equals cosecant squared. This was one of our identities. That means I can just replace this with cosecant squared. So this is kind of the idea of finding just the right Pythagorean identity to work things out. Because now, once I notice this is just sine times cosecant. These are reciprocals of each other. Sine squared times 1 over sine squared. These cancel. We just have 1. So sometimes if you can really find just that right Pythagorean identity, it can really make the problem easy. Not that it was difficult the other way. It's just it was a little easier this way. Not a big deal, but something to keep in mind. If you sometimes just finding that right Pythagorean identity can make all the difference. Ooh, okay, here we go. We got Pythagorean identities all over the place. This one is a little tricky, in my opinion, just basically because which side's more complicated, right? Aren't we supposed to usually start with the more complicated side? But which one is it? Is it this one? Is it this one? I'm not sure. Kind of an opinion piece, I guess, here. I mean, it's probably more difficult to add things to add or subtract together. But what I'm actually going to do is I'm going to work with this side. I'm going to work with the left side and show it equals that. Okay. And the way that I'm going to do this is making use of Pythagorean identities, because that's what we're looking at. I'm going to replace sine squared with 1 minus cosine squared. That is one of our identities, one of the forms of our basic identity. So in doing that, I end up getting tangent squared x times, now instead of sine x, I actually get 1 minus cosine squared x. Okay. From here, the reason I'm thinking about doing that, I want to turn this into subtraction. I want to get subtraction involved in my problem. So I'm doing that right now. I know that I can replace tangent with something, or sorry, with sine with something with some subtraction. Now let's go ahead and distribute this, right? Because now I just want to put these things together a little bit more. So now I end up with tangent squared x times 1, and then tangent squared, so minus tangent squared x times cosine squared x. Looking at my problem, kind of where I'm trying to get to here, I kind of notice I already got this first part locked up. I've got tangent squared. I need to figure out how this piece simplifies to be sine squared. Something about this is going to simplify to just be sine squared. Let's write things in terms of sine and cosine. So tangent can be rewritten. We're going to write, I'm not going to mess with that one. That one's already good. That's exactly what I wanted, but I'm going to rewrite this one. Tangent can be written as sine squared over cosine squared. Tangent squared can anyway, times cosine. Here's where I'm getting that simplification, right? These are going to cancel, leaving me with just sine squared. So there we go. This is what we have. Now we have tangent squared x minus sine squared x. So finding that just right Pythagorean identity can really make things work well for us. This is not the only way to do this problem. There are many other ways to do it. You could probably get away just writing things in terms of sine and cosine and kind of going from there. You could even work with this right side and try to put those things together once you write it in terms of sine and cosine. But I think in terms of speed and like how easy it is, once you notice this, it's like 3 steps. So, you know, this problem might be a little longer in a different method. So sometimes finding just that right Pythagorean identity can unlock things. Not that you have to, but it can. All right, the next thing we have here is fractions. So anytime we have 2 fractions that are added together, almost always our best bet is to put those together, especially in a situation when we're trying to show that this is equal to just one thing. So obviously we're going to have to get this stuff together. So we need to get a common denominator here. So what I'm going to be doing is multiplying both sides, multiplying both fractions by the denominator of the other one. So I'm going to be multiplying this fraction by sine x over sine x. That's the way I get sine x times 1 plus cosine x. And then this one I'm going to be multiplying by 1 plus cosine x. That way I get the same denominator. I'm going to get a denominator of sine x times 1 plus cosine x. I'm going to leave my denominator factored out. And I'm going to do a little bit of work here before I kind of just go writing things out. So here I end up with sine x times sine x, which is sine squared. And then here I got to distribute this, but I get cosine x plus cosine x plus cosine times cosine is cosine squared. And once I have this thing together, this is in a single fraction now, right? I have a common denominator. I'm just adding together the numerators. I got to start noticing kind of what I can do with this. At this point, I see right here I have sine squared plus cosine squared. With a little rearrangement, I can put this in a different order. Sine squared x plus cosine squared x plus cosine x, right? That's just rearranging terms. That's something we're allowed to do with addition. And we know this is just equal to 1. So let's rewrite this whole thing a little bit simpler. I end up having in the numerator 1 plus cosine x over sine x times 1 plus cosine x. And here's the reason I didn't actually multiply out my denominator like this. Look, I have the same thing in the top as I have in the bottom. Those can cancel out. That's why we don't want to multiply the denominator out. The numerator, we have to multiply them because we're going to be combining like terms and seeing what can go together. But the denominator, we just leave it unmultiplied and cancel anything out that's left over. And so now we have 1 over sine x, pretty simplified. Remember where we're going with this problem. We're trying to show that it's equal to cosecant x. And it is. This is simply equal to cosecant x, the reciprocal of sine. This is a pretty complicated process. You got to remember how to get your common denominators, how to work with your fractions. You may involve, Pythagorean identities, all kinds of different things along the way. Anyway, we'll go ahead and pick up doing the rest in part 3. See you guys.